Hello everyone. My name is Dr. Sathyanarayan Rao, and I am a research associate at Indian Institute of Science, and I am working with Professor Shekhar Muddu as a research associate in the project Reward project. So this Reward project is basically the government is improving watersheds in Karnataka and some in Odisha. It's partially funded by World Bank. So basically, field workers go to the slopes in these watersheds and construct some kind of structures like trenches, soil bunds, basically small earth barriers across the slope. The idea is to, when it rains, instead of water just running off the surface, taking the soil with the soil erosion, this structure will prevent soil erosion as well as help slow the water down and retain the water so that it goes into the soil, deeper regions of the soil. And because the rainfall in these regions is very uncertain, sometimes we get heavy rainfall, some years we get drought. The government is spending quite a lot of money here to construct these bunds. The question I'm trying to answer in this work is that did these bunds actually had a measurable impact that we can see via remote sensing, like publicly available data like Sentinel? And if we can see the difference from satellite data, how can we confirm it with whatever TDR data that we have? So for now, although the government is spending money for a lot of watersheds across the states, I just took two tiny watersheds in the Chamarajanagar district to analyze them, like to see if there are any impact of the interventions. What I will do is that first I will talk about these two watershed, where they are located and why it was chosen, and after that we will describe the methods that I used to actually check whether these interventions had an impact based on the satellite backscatter. An important point actually is that these two watersheds were treated in different times. One was treated earlier under a project named Sujala 3, and the other later project, the other watershed was treated by a later project. So now let's talk about the study area, like the two watersheds. Both of these are in the Chamarajanagar district in the Karnataka state, and actually they are actually touching each other. One watershed is upstream and the other is downstream. It's downstream. What happens is when there is heavy rainfall, water can flow from Harave to Mallaiinupura, and the interventions are at different times. As we can see, like Harave actually received these bunds and trenches under the Sujala 3 project in 2018 to 19, and by 2020 we can assume that the structures were fully in place and functioning. Mallaiinupura, on the other hand, actually had no structures for several years. It remained untreated until the Reward project that actually started in late 2024. By 2025, actually, almost most of the trenches or the bunds were constructed. So we had like 5 years, we had like a clean situation where one watershed was with the bunds and one was untreated, and they were sitting next to each other receiving the same rainfall. So we had different rainfall stations that were actually measuring the precipitation. This study is based on a simple logic that if after 2020, after the intervention of Harave, if Harave is showing more soil moisture than Mallaiinupura, it means that the difference could be due to the construction of these bunds and trenches. That's the main idea we want to test. But there is one complication because Mallaiinupura is downstream the Harave. So what would happen if there is a heavy rainfall is that water would flow from Harave to Mallaiinupura. So there is Mallaiinupura might still get some indirect benefit because it's sitting at the downstream. So we will see how we can address this complication. When we look at the rainfall data, we also had some years with a lot of flood, like 2022 was a flood year, and we had a outlier huge amount of precipitation on that year. So this is the basic setup. We have two watersheds that are adjacent to each other. One is upstream, one is downstream. There are different timings for these bund constructions or the soil interventions. We have a clear timeline that allows us to compare before and after interventions. So let's talk about the data that I actually used. Before I go to the analysis, First, I collected the satellite data. So I used Sentinel-1 images through the Google Earth framework, which is actually open source and anyone can use it with a Gmail account. I collected data from January 2016 to February 2025. So it's almost 1 decade. And so I used only the morning passes, like 6 a.m. At that time, soil moisture conditions are actually more stable. The sun has not heated the surface, and so we avoid extra variations due to the temperature. And for Harave and Mallaiinupura, together we had around 200 to 300 usable images for these for each watershed for this period. We had actually slightly more images in Harave because its position is relatively close to the satellite path. But from these images, I extracted around 800 points, roughly 400 points in Harave and 400 points in Mallaiinupura, and they were chosen so that we had equal representation of each soil classes. So these points were not randomly chosen. We had different soil types, and we also filtered out areas like villages, human settlements, railway tracks, rocky patches. All these things were removed from these points. For example, we also removed points that were within 100-meter radius of any existing bore wells. We had this information because that means that a farmer might be irrigating since that area has a bore well, and that would introduce noise. And we only want actually the rain-fed agricultural land to see the impact of this bund construction. So we also removed some flat regions because bunds are not constructed on flat regions. They are constructed on slopes. So if there is no slope, there is no bund effect. That's the idea. So we focused on only slightly sloped agricultural regions with equal representation of soil classes, rain-fed regions indirectly. So with this in mind, we had around 400 backscatter points in Harave and 400 in Mallaiinupura. And next we also had the rainfall data. So we had around 10 to 13 weather stations in the region. So we took daily rainfall readings and converted them into monthly totals. Since both watersheds are next to each other, they actually share the same rainfall network. Now about the rainfall pattern, the period 2016 to 2017 is our baseline because both of these watersheds are untreated, and annual rainfall is roughly between 480 to 820 mm. Only 2022 was little bit a flood year. It had 3 times the rainfall of a normal rainfall, and so we exclude 2022 from our analysis because it's clearly an outlier. And the 2025 was opposite. It was a drought year with only 420 mm of rainfall. So this year can be useful to actually test the stress test of our bunds. We can check if the bunds still help when the rainfall is scarce, because that is their purpose actually. We also had some ground measurements, like in 6 locations in Mallaiinupura we had TDR probes, and these measured soil moisture from 10 centimeter up to 80 centimeter in depth. We had around 1600 readings across 2 periods, like 2023 to 2024 before the reward bunds, and 2025 afterwards after the bund construction. These are the data we have, like the satellite data, rainfall data, ground measurements. So now before we actually claim that soil bunds or trenches made a difference, we need to first check that whether these 2 watersheds already was behaving the same way before any interventions. Because one might ask that if Harave was naturally wetter due to some soils, or it had different soil properties or something, even before bund constructions, then any later difference that we see cannot be fully attributed to the soil interventions made by the trenches. So it could simply be an existing pattern. So we have to prove that during the baseline period in 2016 to 17, during this time neither Harave or Mallaiinupura had any bunds. So both were untreated, and both were receiving the same rainfall. So if we can show that both of these watersheds were hydrologically equivalent, they were the same, then any difference that we see in the later years can be attributed to the bunds. So what we did is that for every satellite image during this period, 2016 to 17, where both watersheds did not have any intervention, we computed the ratio. For example, Mallaiinupura backscatter divided by Harave backscatter. So if both watershed respond to rainfall in the same way, then this ratio should be equal to 1. And this is exactly what we see. So for example, in this figure, the blue line is Harave and the orange line is Mallaiinupura. You can see that during 2016 to 17, they moved together. The average ratio was around 1.01. This is exactly almost 1. And we also calculated some statistics, for example, t-test, the Cohen's t-test, or the p-value. All of them showed that the difference, they were basically, they tell the same story that before any intervention, these two watersheds were hydrologically equivalent and they responded to the rainfall in the same way. And this is very important to show that, because now if after 2020 we see them diverging and we know Harave already has bunds now, then we can more confidently say that the change is due to the intervention and not because they were different from the beginning. So this is the baseline check that we did, is the foundation for any analysis that follows this. So now we try to answer the main question: did the soil intervention or this bund construction, did it work? So for that we just cannot compare Harave before and after bund construction, because soil moisture can change over time for many reasons, not just the bunds. So instead what we do is we compare how much Harave changed and we compare how much Mallaiinupura changed during the same period. So the logic is like, let's say Harave before bunds, let's call it as A, and Harave after bunds, after the intervention, after this construction of trenches, let's call it as B. So the Harave improved by B minus A. Similarly, Mallaiinupura before bunds, let's call it C, and Mallaiinupura after the construction of bunds, the reward project, let's call it as D. So Mallaiinupura improved by D minus C. Now the Bund effect is Harave improvement minus Mallaiinupura's improvement, or in symbols it's B minus A minus D minus C. So in plain words, how much extra improvement did Harave show compared to Mallaiinupura? So if Harave increased by 25% and Mallaiinupura increased by 5% during the same years, then the Bund effect is 20%. In difference method, we focus on the change, not on the absolute values. So it does not matter if Mallaiinupura is naturally wetter. It does not matter if overall conditions improved in both watershed. What matters is that did Harave improve more than Mallaiinupura after bund construction in Harave? That extra improvement is what we attribute to the bunds, and this is what we call as difference in difference method. And now let's look at the timeline. So 2016 to 17, both of these watersheds were untreated. It's the baseline. 18 to 19, Harave construction phase. 2020 to 2024, Harave was treated. The bund is completed, but Mallaiinupura is untreated. And 2025, Mallaiinupura is also somewhat treated due to reward project. After 2020, Harave begins to show slightly higher or more stable soil moisture compared to Mallaiinupura. And in this figure, actually, we show the difference between Harave minus Mallaiinupura in the backscatter value. So during the baseline period in 16 to 17, the difference fluctuates around 0, and after 2020, the rolling average shifts actually. This tells something has changed after the treatment. That shift is what we measure in the regression. So here we discussed the main quantitative part of this study. So we built a regression model where the monthly radar backscatter is the thing we are predicting. So each data point in this model is one watershed, 1 month. So for example, if we consider January 2016, we have Harave, the average backscatter across all grid points, and Mallaiinupura, the average backscatter across all the grid points. Like we had 400 grid points in each of these watersheds, and we also have rainfall, same for both because they share the same weather station. So in January 2016, we have two rows in the dataset. Each row contains watershed name, average backscatter, and the monthly cumulative rainfall. So from 2016 to 2025, excluding the flood year 2022, we had around 210 points. So this is our dataset. So you might notice something like earlier I explained difference in difference idea, like using four values A, B, C, D, like Harave before, Harave after, Mallaiinupura before and Mallaiinupura after during the same period. So the calculation that I showed was change in Harave minus change in Mallaiinupura. And now suddenly we are having here regression. Actually, the regression that I'm showing here is simply the statistical way of doing the same comparison. So instead of using just four averages, the regression uses all monthly observation from 2016 to 2025, while also adjusting for rainfall and the natural downstream advantage of Mallaiinupura. So ideally, the key coefficient gamma 1 actually represent the difference in differences effect. Now we also need dummy variables. They are just 0 or 1 flags that tell the model which category a data point belong to. So a Mallaiinupura dummy is 1 if that row is Mallaiinupura, 0 if it is Harave. Similarly, if I define a post-Harave dummy, it is 1 if the watershed is Harave and it's after 2020. That means after the construction of bunds or later. Otherwise, it's 0. So it's a treatment indicator dummy. It activates only after Harave's bunds start functioning. So this equation is our main regression model. So here sigma naught is alpha times alpha plus beta rain delta Mallaiinupura plus gamma 1 post Harave plus epsilon. So this Mallaiinupura and post Harave are dummy variables. So alpha here is the baseline backscatter. When the rainfall is 0 and we are looking at Harave before treatment, it's our starting point. So beta is actually tells how much backscatter increases per millimeter of rainfall. So from our results, it was about 0.028 per 100 millimeter. This is the rainfall effect. So both watershed share this. And delta actually captures how much wetter Mallaiinupura naturally is compared to Harave for the same rainfall before any treatment. From our results, it was plus 0.014. It was a positive number. It's because Mallaiinupura is downstream. It had a downstream advantage as we discussed earlier, and so it naturally collects more water because it is sitting lower than the Harave. And here the gamma 1 is the key variable because it tells how much Harave's backscatter increased after the bund construction. Because we have the post Harave dummy variable, it activates only after the bund construction. So this gamma 1 tells us after adjusting for rainfall and the downstream advantage how much Harave's backscatter increased, which means the soil moisture after we constructed the bund. And the result is 0.021, which is about 20% of the baseline. So this is the Bund effect. So what this regression is actually doing is that it is separating three effects that are all mixed together in the raw data. For example, we have the rainfall effect, wet months are wetter, dry months are drier, downstream advantage, Mallaiinupura is naturally wet, treatment effect, what the bunds actually contributed. If we do a simple comparison, if we only compared Harave before versus after, the rainfall difference across all year would distort the result. A wet year after bunds would look like success, even if bunds did nothing. And if we only compared Harave versus Mallaiinupura at one point in time, the natural downstream advantage would again distort these results. So this regression removes both a distortion simultaneously, and that's why we use this structure. And the result is the gamma 1, which is the main Bund effect, which we see around 20% here. And the p-value is 0.001, which means it's statistically significant and it's not happening by any chance. So Harave gained 20% more soil moisture after treatment, and it is statistically significant. So in this video we established that both watersheds were behaving the same before any intervention. Second, after adjusting for rainfall natural downstream advantage, Harave showed a clear increase in backscatter after bund construction, and the increase is not random, it was statistically strong. And in part 2 of this video we will continue this story where we will look at soil specific impacts. So we had clay, sandy loam and loamy sand. We will check whether the gains due to these bunds actually meet the World Bank standard, the World Bank targets, and did any of this soil had a better impact due to bunds. So that also we will look, and we will see how the TDR ground measurement, do they confirm what the satellite is detecting? Does the deep root zone soil moisture increase? And we will also look at Mallaiinupura in detail, what happened due to the reward implementation. After 2025, did Mallaiinupura show a similar impact? We will also try to answer, did the Bund effect persist over time? Did the structure lose effectiveness after a few years? Or whether these investments really hold their value? So this will be the part 2. Thank you for watching. Keep learning and enjoy life. Thank you.